All right, let's take a few minutes and take some questions here to start. So at this point, I think we've assigned up through 60. Does anybody have any questions from homeworks or whatever? Kate? 19? I can't do all of those today because it's literally too much time. But I was pretty sure you turned in the homework, so I don't know why you would have questions on all of 1 through 42.
It's too much time. Why is it homework?
All right.
We need time to do stuff too. Could be like 1 through 18.
So, what do we? Okay, 19. Kate says 2 concentric circles are cut by the same angle. So I'm going to start by drawing a picture. When I say concentric, we mean that like one circle is like inside the other one, so they share the same center. And we're told they're cut by the same angle. So there's our angle. The radius of the smaller angle is 4.3, and the cut arc is 5.2. If the radius of the larger circle is 5.2, what is the length of its cut arc? So the other piece of information that I have, or that I know I need for this situation, is the angle. So I'll represent that with the angle theta. Now I remember that in radians, we know S is equal to R times theta. Now I know that this theta is the same theta for R1S1 as it is for R2S2 from the picture, right? We can see that. And I know R1S1, so I'm going to use that information to solve for theta. And then I'll use that answer for theta to plug into the other formula to get S2. So S1 is 5.2. R1 is 4.3. To get theta by itself, I'll just divide both sides by 4.3. So far, so good. And now I'm going to go ahead and plug that answer into the other problem. And I know that R2 is 5.2. And now it's just calculator time. So 629-ish. Does that feel okay, Kate?
How do you know where to use radians and when to use degrees?
Could have used either.
Okay.
It wouldn't have mattered. I chose to use the radian formula because it's like way simpler. There's just like less stuff going on. There's no fraction. So I just chose to use it since I'm not actually looking for theta. The unit for theta didn't matter. So I just used the radian formula because well, it's just easier.
Yeah.
Miriam.
Can I do number 4?
Number 4? Yeah, sure. So here it asks to convert from degrees to radians. It says leave your answers in terms of pi when applicable. Otherwise, round to nearest hundredth. Notice that I have a decimal for my degrees. So when I do this, I'm going to get a decimal answer. So to go from degrees to radians, my conversion factor is to multiply by pi over 180. Should be easy to remember that because the degrees have to be on different levels so that they cancel out, just like in your chemistry class or whatever when you do your unit conversions. And so now it's just calculator time. So 37.41 times pi divided by 180. And my answer is 0.065.
Oh, never mind. I was confused with the hell of
Just putting in my calculator and rounding. Grace.
So, like, when do we know whether to keep it in pi? Is it going to tell us?
Well, like, this is a good candidate because one, it doesn't have a decimal, and two, I can see really quickly that 180 and 120 reduce really nicely, right? They both contain a factor of 60. So that one I would leave in terms of pi. But like 19.4, 51.89, 289, I would probably convert all those to decimals. I mean, 289 technically you could probably reduce. That's, I don't know. I think that might be prime. Looking at it, I can't tell right away. But I don't know that it shares a divisor with 360 anyways. I mean, you could write it as 289 pi over 360, I guess, if you wanted to. Mr. Simmons, what can I do for you? Yes. Yes. Go ahead, Francesca. Does that satisfy you? Maya, I thought I saw your hand. Did you have one? Just must have been like knowing you're in line. Just gave you the inspiration. Sometimes kids will walk up and get ready to ask a question. They'll be just turn around and leave. They're like, oh, I figured it out. And it's like, just must be the proximity to my greatness that did it. Jacob.
Don't you plug in the calculator for the 37.41?
I just typed in 37.41 times pi over 180. Wade? 13? Sure. So here, the first order of business is to look at theta because I have two different arc length formulas. And the two different formulas depend on the unit in which we're measuring theta. I notice in 13 we're measuring theta in degrees. So I'm going to use in radians. Woo! Circled it. We're measuring theta in radians, so I'm going to use the radian version. And then I'm just going to plug in my values. And then type it in my calculator, and that's my answer. $252, and the unit there should be, it's the same arc length as a length, so the length unit from the radius should match up with the length unit for the arc length. So inches. I'm done. Yeah. Just filling it into the formula and finding the missing piece, right? Well, it's no different. I mean, does that matter though? I mean, I have R, I have my theta. I'm just going to do it the same way. Just type it in my calculator. You know? So 1.71. And the unit there should be meters to match the unit on the radians. Or the radius, excuse me. Does that feel good? Any other questions? Happy to do some more. Miriam, is that a hand?
Yeah.
Sure.
Okay. Can you do number 40?
Yeah, sure. So here's 40. So what I do is I want to start by looking at the angle that's given. Relative to angle B, the side that's given is opposite, adjacent, or hypotenuse. So that's opposite. And the side we want to know is adjacent or hypotenuse? Adjacent. So which trig function should I be using if I have opposite and adjacent? Tangent. So I'll say tan of 88 equals opposite over adjacent. And I'm just going to solve for A. So I'll multiply A to both sides to get A out of the fraction. And then divide both sides by tan 88 to get the A by itself. And then it's just calculator time. Now, before I type this into my calculator, what should I check? Yeah, I should check my mode, right? So I am in degree mode. So I'm good. But if you haven't checked your calculator in a while, you probably want to do that. Or if you borrow a calculator from someone, you definitely want to check that. Press the mode button right next to the blue second button. The third option, I think, is radian or degree. You just, if degree isn't highlighted, you use your left, right, up, down arrows to move over to highlight the degree and press enter.
Thank you.
Yep, and then you press second in mode to get back to the main screen. Miriam.
Sorry, one more question. How can you like go over like how to like find a product calculator? Like, is it here like that?
Yeah, well, you can't do that one without a calculator. Because the only
there was just like whatever it applies to, like how to find it.
So the without a calculator problems would have to involve a 30, 60, or 45 degree angle, or the equivalent in radians. So like pi over 6 is the same as 30 degrees. All I did was multiply that by 180 over pi to get that. So if I draw a right triangle with a 30 degree angle, well, I notice that that's a 30, 60, 90 right triangle. So I know the ratios there. And I know sine of 30 is opposite over hypotenuse. So that just reduces down to 1/2.
Okay.
So it's just, you're going to be drawing either a 30, 60, 90 or 45, 45, 90 triangle to do that. If you're asked to do it without a calculator, those are the only two situations you can do. What if we had a problem like this one up here?
Is that like, are you saying what if, like, we're about to do?
I mean, could be.
That's a great question.
Let's do. So what if I want to solve this triangle? So Iden says let's start by finding this side B. So he knows that using the Pythagorean theorem that 12 squared plus b squared is equal to 15 squared. What do we have to be careful about? Not to square root the whole thing, but also the hypotenuse has to be the part that's all by itself, has to be the c squared, right? So 12 squared is 144. 15 squared is 225. If I subtract the 144 from both sides, I get 81. And the square root of 81 is 9. Now, how do I find the angles A and B now? Well, let's pick one to find. Which one do you want to find first? B, okay? Now, relative to angle B, we need to pick two sides that we know. Which sides do you want to use? 9 and 12, okay? Relative to B, the side 9 is opposite, adjacent, or hypotenuse. Opposite. And the 12 is adjacent. So which trig function should I use? So I'll say tangent of B equals opposite over adjacent. And then get the B by itself, I have to get rid of that tangent part that's around it. What is going to cancel out tangent? Tangent inverse. Good job. So I'll do tan inverse of both sides. So those cancel out. So B is equal to tan inverse of 9 over 12. And then it's calculator time. So second tan gets me the inverse. And I'll do just 9 over 12. And my answer is 3687. What's angle A then going to be? Yeah, 90 minus angle B. I remember the acute angles of a right triangle I have to add to give me 90 degrees. So what's that going to be? 5313. How did I do the inverse again? To cancel out the tangent, to get the B by itself.
Oh, okay.
So I did to both sides. So the tan inverse canceled the tan, leaving me just B on the left. And then the other side I just typed in my calculator. Again, what do I have to be careful about? Typing into my calculator? I have to make sure I'm in degree mode. Good. Everybody's in degree mode. All right. Let's do this thing, right?